first part from today, it says question number 1, find the area of each regular polygon. And then I know for this one, that's when I introduced you guys to the word apothem, which is from the center there. The area of a regular polygon is 1/2 times the apothem times the perimeter. Obviously, for perimeter, you guys can see one side is 13.3. There's 8 sides. So for the perimeter, I'm going to go 13.3 times 8. So since we're more likely going to use a calculator, I'm going to use decimals. 1/2 is 0.5. The apothem in this case, 16. For the perimeter, I'm going to go 13.3 times 8. 106.4 for the perimeter, right? All right, so if you guys go 106.4, to repeat it, then you guys do that. So 1/2 times the apothem times perimeter. Multiply that out, and you should get 851.2. And it could be any shape. I gave you guys what, like 6 of these? So I gave you 6. There's 2 of these in the final. Only 2, yeah. Remember, the final is only 76 questions long. Oh. All right, guys. So any questions on the first 6? Jessica, yeah. Number 3. All right. So looking at number 3, I'm gonna go 1/2. I know we talked about triangles yesterday, and I said 1/2 times base times height. But if you notice, I'm not giving you the whole height. I'm giving you the apothem. So I'm going to use 1/2 times apothem times perimeter. I'm going to treat it the same thing. So 1/2 is in decimal 0.5. The apothem in this case is 13.9. For the perimeter, I'm going to go 48 times 3. If each side is 48, there's 3 sides, so that's why 48 times 3. Multiply all that, and you should get 1,000.8. I'm writing it to the nearest tenth, 1 decimal place. For those 6 questions, yes. 1/2 times apothem times perimeter. You guys might come and say, well, they have different sides. Does it work? With the perimeter, that's why it compensates. So yes. If you guys just remember 1/2 AP, apothem perimeter, 1/2 AP. That's basically it. If you guys want to write formulas there, remember I'm asking you guys to keep this paper till next week. You guys have your final next week. Keep your papers till then. If you guys want to write formulas, want to write yourself a note, write yourself a note. That way you get to see it. All right, so let's take a look at number 7. Find the area of each sector. I know the area of a circle. I need the radius. The radius is 10. So if I was looking for the area of the circle, knowing that area is 10, I'm going to get the area of the circle will be 100 pi. Because I went 10 square, right? Radius square. So the area of the whole circle will be 100 pi. Let me make this into a fraction. So I'm going to put a 1 at the bottom, and I'm going to multiply by how much of the circle I have. I have 135 divided by 360. I'm going to show you guys a trick today. This 135 and 360, I know they're divisible by 9. I don't know by how much, but I know they're divisible by 9. And the trick I'm going to show you guys is that if you add the numbers of any digit, any number you can come out with, if you add the numbers and what you come out is divisible by 9, then that number to begin with was divisible by 9. That's a trick that works with 9 and 3. What I mean with that is, imagine I had like the number 270, or better yet, I had the number 279. If you add those numbers, add the number 2 plus 7 plus 9, you get 18. 18 is divisible by 9, so 279 is divisible by 9. You guys see how here at 135, add the digits, 9. So 9 is divisible by 9, so 135 is divisible by 9. And so is 360. So I'm going to divide this by 9. 135 divided by 9, I get 15. 360 divided by 9, I get 40. I know 15 is not divisible by 9, because if I add the digits, it's not divisible by 9. But 15 over 40, we can divide each by 5, and then we get 3 over 8. So I can say you guys can learn how to check if it's divisible by 9. I know here I multiply straight across. When I multiply fractions, I multiply straight across. So that's the only way you cannot simplify. So the 8 and the 100, we can simplify those as well. 108, let me divide each by 2. So let me divide each by 4. So 100 divided by 4 is 25. 8 divided by 4 is 2. 108, I divided each by 4. Now when I multiply across, 25 times 3, it's 75 pi. At the bottom, 1 times 2 is 2. If you have the type of calculator that already simplifies your fractions, then don't worry about simplifying. Or if you have one of those calculators. If you don't, then yeah, you have to simplify. All right, so any questions up until 12? There's 2 of those on the final. Bless. Now looking at question number 13, I'm looking for the length of each arc. So the questions look similar, the figures look similar, but now I'm asking for the length. I know for the length, since the radius is 6, I'm going to say the length around the whole circle is 12 pi. Because I go diameter pi. The radius is 6, so I know the diameter is 12. So the area, so the diameter pi. So yeah, let me write the formula. The circumference, which is the distance around the whole circle, circumference is diameter pi. That's the distance around the whole circle. Let me make this into a fraction, and I'm going to multiply by how much of the circle I have. 255 divided by 360. I know this case, they're divisible by 3, because the rule with the 9 works with 3 as well. I know they're not divisible by 9. 255 is not, but it is divisible by 3. And then I know they're divisible by 5 as well, so let's divide it by 15. So 3 and 5 is 15. So let's divide each of these by 15. 255 divided by 15 is what? 17? 360 divided by 15 is what? 24? 17 over 24, yeah, there's nothing we can do. And I know I multiply straight across, so that's the only way I cannot simplify. But 12 and 24, that can be simplified. That's going to become 1 and 2. I divided by 12. So now when we multiply straight across, 1 pi times 17, on top I have 17 pi. At the bottom, 1 times 2 is 2. Some of your fractions might be a whole number, because your fraction can simplify to a whole number. So 17 pi over 2. There's 2 of these on the final as well. So any questions up until 18? Now looking at number 19, I know this one kind of gave us a little hard time. Find the surface area of each figure. Round your answer to the nearest tenth if necessary. When we're looking at decimals, tenth sounds like 10, and I know 10 has 1 0, so 1 decimal place. When we get asked for hundredths, I know 100 sounds like 100. 100 has 2 zeros, so 2 decimal places. So in this case, 1 decimal place. For surface area of prisms and cylinders, I know I told you guys it's a big rectangle in the center always, and then 2 bases. The bases can vary. They can be circles if it's a cylinder. They could be triangles. They could be pentagons. They could be whatever. In this case, they're going to be rectangles. I know for a prism, what it makes a prism is two bases, one on top, one at the bottom, and everything else are rectangles. So if I see a side that is not a rectangle, for example, if I was looking at number 20, the circle is the base. If I was looking at 21, well, that's a circle as well. It could be a triangle. It seems like I don't have one on the review, but it could be a triangle if you need it. But when everything is a rectangle, like our case, just pick one rectangle to be the base. So I'm going to choose this 11 by 9 to be the base, which you guys can see is at the bottom as well. Once again, when they're all rectangles, you have a choice on which one is the base. So it's an 11 by 9 rectangle, and I know the area of a rectangle in this case is 11 times 9. So each base is going to be 99, right? 11 times 9, the area of the base. For the big rectangle, this small side will be 9. It's a number that has nothing to do with the bases, right? The height. So 9. I'm looking at this 9. The long side of the rectangle, I'm going to write it over here, add all the sides of the base. The base has 4 sides, so add all 4 sides. 11 plus 9 plus 11 plus 9. Add them all 4, and you should get 40. Okay, I added all the sides. If the base was a triangle, remember I just went 11 plus 9 plus another 11 plus another 9. I added the 4 sides of the base. That's how I got the 40. If the base was a triangle, add the 3 sides. There's only 3. All right, so I know 40 times 9 is 360. So the area of the big rectangle is 360. Remember, this is the height, and this is the perimeter of the base. Then just add everything. That's what, 558? That's it. Just that the distance around the circle, we don't call that perimeter, we call that circumference. And remember, I gave you guys the formula for that earlier. If we had something like this, there's the big rectangle, my bases are circles. On the big rectangle, I know 10 is the small side, but over here, the distance around the circle is going to be 24 pi. Because remember I told you guys that circumference is diameter pi. That's the distance around the circle. So for the rectangle in the center, it's 240 pi. 24 times 10. The areas of the circles, you guys can get those on your own, and then add everything. So for surface area of 19 through 24 of prisms and cylinders, there's 2 of those on the final. The base could be triangles as well. I could change the shape of the base. But remember, it's a big rectangle and 2 bases. There's 2 of those. Any questions up until 24? I'll give Jessica one, but what was it?
How do you find out the circles just by r squared? I mean r squared.
R squared pi. So yeah, each circle in this case will be 144 pi. Because it's radius squared. And then add everything. And yes, Jessica, you had a question? 23? Well, 22? All right, looking at number 22, I know it's going to be a big rectangle and 2 circles. I know for the big rectangle, this small side is 9. That is a number that has nothing to do with the bases. Since the radius is 4, I know the diameter is 8, so the long side will be 8 pi. So if I multiply those 2 numbers, 9 times 8, I'm going to get this rectangle to be 72 pi. Since the radius is 4, I'm going to say the circles are 16 pi. It's 4 squared. And then add everything. Should be like what, 104? Yeah. 104. So anything up until 24? 21. I know I have to do a big rectangle. In this case, the bases are circles. On the rectangle, this small side is 5. The number has nothing to do with my circles. Here, the diameter is 18. So the long side of this is going to be 18 pi. Notice how I gave you the diameter this time. Not the radius, I gave you the diameter. I know 5 times 18 is 90. So this is 90 pi. Since the diameter is 18, I'm going to say the radius is 9. So we know the radius is 9. So since the radius is 9, I'm going to say each circle, it's 81 pi. Because 9 squared. Then just add everything. I'll let you guys finish those on your own. But let me take a look at number 25. When we have a pyramid, I look at the pyramid and the base, it's a hexagon. We can see the base is 6 sides. So as a matter of fact, let me do my hexagon here. 6 sides. And I know at the beginning of today's worksheet, we talked about the area of a polygon. I even said, remember half AP? 1/2 times apothem times perimeter. So at the side, let me think 1/2 times 6.9. And then the perimeter is 8 times 6. Let me just call it 48. 1/2 times apothem times perimeter. Just for the base, I get 165.6. That's the hexagon in the center. Now, on pyramid, there's the base, and there's a bunch of triangles, one triangle on each side. In this case, 6 triangles. If I look at one triangle, the two numbers that cross the 90 degrees are 13 and 8. I know this side is 8 because each side is 8. The two numbers that cross the 90 degree are 8. So for the triangle, I'm going to go 1/2 times 8 times 13. Multiply the two numbers that cross the 90 degrees, and don't forget the half of it. That should be 52. So each triangle is 52. Then just add everything. Add everything and you're done. Cones has their different way. Like I said, this one I didn't finish. Just add everything. You should get 477.6. But when it comes to a cone, take a look at this one. I know I told you guys they used to spread to a circle, and then this other part looks something like this. The radius is 1 on the circle. The radius is 1. So the area of the circle will be 1 pi. Because remember, keep in mind, I went radius squared, right? 1 squared, still 1. So radius squared. Now for this other side, I'm going to multiply the radius with 6.1. So 1 times 6.1, I get 6.1 pi. You multiply the radius and the lateral height. Multiply those two numbers and pi. Then just add everything. In my case, I should get 7.1 pi. Remember, the circle is radius squared. For this other side is radius times the lateral height. People call it slanted height sometimes. Number 30? Okay. Looking at number 30, the circle and a thing that looks like this. The radius is 11. Right? The diameter is 22. Radius is 11. So for the area of the circle, I'm going to get 121 pi. Right? 11 times 11. For this part right here, let me multiply 24.6 times 11. I get 270.6. And then just to finish it off, let me add everything. You should get 391.65. Yes. How did I get the 270.6? Because I multiplied 24.6 times 11, the radius. Okay. And then from pyramids and cones, there's also two of those on the fine. Now the last part, volume. Starting on question number 31. I know for prisms and cylinders, I used to tell you guys the volume was the area of the base times the height. Remember, base is a shape. In this case, I'm going to choose this rectangle, this 4x5, to be the base. The area of a 4x5 rectangle, the area of the base is 20. We just go 4 times 5. The height is a number that has nothing to do with the bases, so the height is 10. So area of the base times height, I get 200. Remember, the measurement is always inches squared. I'm okay if you guys don't include the measurements. I will include it, but you don't have to include the measurements, the units. I'm more interested in the number, 200. So for prisms and cylinders, it's area of the base times the height. Then we move into, just look at this one. The base is a triangle, right? Don't forget how to get the area of a triangle. I'll come back to the sphere in a minute. When it comes to pyramids and cones, I remember that was area of the base times height divided by 3. And I know when I covered this, I did water, and I filled it 3 times. So that's why it's divided by 3. So here, the base is a rectangle. It's a 9x6 rectangle. So the area of the base is 54. The height, we can see, is 9. We can see the height is 9. Let me divide this by 3. That gives me 162. Area of the base times height, so 54 times 9. And what you get, divided by 3. Should be 162. So area of a cylinder, or a pyramid or cone, is area of the base times height divided by 3. But let me come back to the sphere, because this one's a little bit different. This one, the volume is 4/3, 4 divided by 3, times radius cubed times pi. Make sure you work the radius first. Your radius is 6. Right? Your diameter is 12, so you know the radius is 6. So do the radius first. 6 to the third, right? 6 times 6 times 6. Once you get radius to the cube, multiply it by 4. Because when you deal with a fraction, once you get radius cube, multiply by 4, and then divide by 3. Once again, get your radius to the third first. So 6 times 6 times 6. Then multiply by 4 and divide by 3. You should finish with 288 pi. 6 cubed times 4 divided by 3.
So on 38, and on would do 130.
On 38, 37 and on, yeah. Area of the base times height divided by 3. With 38? Okay, let's take a look at number 38. Now, volume is the area of the base times height divided by 3. So the base is a pentagon. We can see our pentagon there. So I know for the area of a pentagon, I go 1/2 times 6.9 times 50. 1/2 times apothem times perimeter. Once again, 1/2 AP. So that's the area of the base. The height is 8. You can see the height is 8. And then divided by 3. Perimeter. 10 times 5. So the area of the base times the height divided by 3. You should get 460. In volume, the measurements to the third. All right, guys, so for questions 31 through 42, there's going to be 6 of those on the final. I'm thinking, I think I did 3 prisms, cylinders, whatever, 3 of those, and then 3 pyramids and cones. So it's a total of 6 from those. So today we review, 16 questions from the final. I was telling you guys how many there were on each. And remember, the final 76 questions long. Any questions?